Welcome back to codingcat.dev, where we give you cats the freshest dose of dev snacks. Authzed, stop building Authz, start building value. Sam and I met a while back at a conference, and I'm in kind of the authentication space at FusionAuth. Sam's at Authzed in the authorization space. And I don't know, we got chatting about kind of both tools and where they would fit. I'm like, I got to have you on the podcast. We got to talk about this more. So Sam's here today to talk kind of all about authorization and, ReBAC and SpiceDB, which is part of Authzed. And, we're going to break all of it down, and we got some little examples to show off too. So can't wait to get started. But first of all, Sam, I did a little snippet. Do you want to break down a little bit more about your role and what you do at Authzed?
Sure. Yeah. At Authzed, my official title is software engineer. Which means day to day, I'm coding and building and kind of in the service of fixing access control. But I think, and I've been here at Authzed for over 4 years now. And so what that has meant is that my day-to-day job has shifted quite a bit. Initially it was kind of building our product and kind of working on our main open source project. But nowadays I've been kind of exploring and seeing how I can just get more people introduced to building better access control using our products and kind of communicating really just the exciting solutions that I think we have that could really help other people build their products. So yeah, day to day, still building, but at the same time, shifted quite a bit recently.
That's awesome. So are you doing a lot of conferences still?
We're trying. Yeah. We're trying to get out there. There's nothing beats kind of talking to people in person.
Kind of seeing what's going on. That's awesome.
So we're trying to get out there.
Well, we're going to start out with, just for my own sake, so coming from the authentication side of things, so that's kind of telling the who a person is, and actually like we'll get a little bit nittier than that. So we talk about JWTs or JOTs, and like that's who a person is, some other details about the application, things like that, and then like permissions in there. And we're going to talk all about like what that actually looks like and kind of what comes into that when you talk about authorization as well. But before we dive into like specifically the Authzed piece, I just want to break down, there's probably about 4, I would say, different models that I want to talk about. And this is where your expertise comes in far more than mine, Sam. I know a little bit about it and like can have suggestions, but so there's RBAC, role-based access control, and yes, I'm cheating off a list, so I don't know these by heart. ABAC, attribute-based access control. PBAC is policy-based access control, and ReBAC is relationship-based access control. We do have a chart on this at FusionAuth. So this is kind of a breakdown that we kind of offer here of those different ones. And we can cheat a little bit, but ultimately, Sam, I want to talk about kind of where you fit in this, and maybe even dive into like, what is this thing Google created, first of all, with Zanzibar? Where do you want to get started first, Sam?
Yeah, no, you did a great job of kind of going through all the acronym soup. Yeah, it's kind of unfortunate they all sound the same too, which just adds to the confusion.
I know, that's so rough.
Just high level, I think RBAC, so role-based access control, is I think the thing that people almost always think about first when they think about authorization or permissions, just because for whatever reason, most user interfaces that you interact with around application permissions kind of implement this today. So it's, if you're an admin, you can do something, or if maybe you have slightly less access than an admin, so you're like an editor, so you can do a few less things than the admin, and then, down the line to like you're just a viewer, and all you can do is, you only have read-only permissions. And so RBAC is kind of long-standing kind of approach to access control. And a lot of times it's hard to kind of imagine a different way of approaching what you can do in an application outside of just roles. It really is just one way to approach access control. It's very user-friendly, but it certainly has limitations depending on the application. I think the next one, there's ABAC. So ABAC is the idea of using attributes. So think, and that's super broad, but just pieces of data that you incorporate, and based off those things, you make decisions around whether something has access or not. Typically, people interact with this in like AWS.
That was going to be my comment. I think that's probably it's most well known for, right?
Yeah. And so, these are nice for kind of access controls that are kind of determined by machines. So they collect up a bunch of maybe context around a request. They do some processing based on some rules, and there you go. You kind of have the information you need to make a decision. PBAC, so policy-based access control, is kind of similar to ABAC in the sense, because usually you have attributes that you incorporate into some sort of policy, but it's kind of what it sounds like. You have a policy that is kind of a definition of some rules or heuristics around whether something has or doesn't have access. And those are usually federated to different places in your distributed system. And you have these decision points where you evaluate those policies and you determine access. And those are nice because I think intuitively it kind of makes sense. Is if you can write code, or you can kind of write some sort of description of what should happen or what shouldn't happen, that kind of fits into this idea of a policy.
Totally. I think I've seen this like mostly in I would say high enterprise stuff, but like government controlled things, I see this all the time.
Yeah.
I don't know why they lean towards it, but
it's a good question. It's either that or actually very kind of like smaller scale applications where a lot of times you'll see kind of as listed as a benefit where you can do like policy as code. Yeah. And so a lot of JavaScript frameworks, I think Rails plugins do this a lot, where essentially the frameworks kind of give you this little box where you can write some code snippets, and that acts as your policy. And it's nice for engineers because obviously, it's very intuitive for us to think in code. And so if you can write access control rules based off of a function, for example, you evaluate the function, it returns true, you get permissions. If it returns false, you don't get permissions. It's very natural for an engineer to think this way. So you see it a lot in kind of web and smaller kind of like application frameworks.
Cool.
And then, the last one was ReBAC, kind of biased toward this approach because one of the nice things is that you can actually model the previous three access control approaches in ReBAC, depending on the solution. ReBAC is it's a very generic construct. Is you have objects, you have relationships between these objects, and you get to apply different rules based off of the connections between them in order to kind of make authorization decisions. And so, spoiler alert, SpiceDB, which is the project that I work on, we've built functionality in our approach to ReBAC that lets you model RBAC, ABAC, PBAC. But we think that having a more generic tool means that you get to evolve your authorization approach kind of based on your application needs. You're not really limited to a specific kind of model. Like you don't have to decide it and you're stuck with it. You can kind of evolve and iterate as your application changes.
I'm hesitant to put this up, but this is the title so far. It might look different on YouTube because I've iterated about 7 times. But so what we're here to talk about is kind of scaling permissions with SpiceDB, which Sam, you could probably talk more about like where SpiceDB comes from, but ReBAC explained. So like this whole kind of episodes, it's mainly going to surround ReBAC and how you use it. And like Sam's got a whole demo thing. And so that's what we'll go through next. I do want to put a quick pause in for our sponsor here, and we'll be right back after. Users, teams, roles, sharing. Is your permission system a tangled mess? Every new feature means a week untangling this mess. How about instead you have one permission system with unlimited possibilities? Authzed is that solution for you. Eliminate authorization silos and simplify your architecture with a centralized permissions platform. One authorization system for your entire application ecosystem. Are your developers sick of writing authorization rules every time your business needs change? There's a better way. Authzed delivers a centralized authorization system so you can define permissions once and enforce them everywhere. With Authzed's flexible configuration language, you can adapt to complex business models without rewriting your code. Worried about scale? Authzed is built for global scale and performance, ensuring a lightning fast and reliable experience for your users, no matter where they are. And with strong consistency guarantees, you can ensure uniform access control across all your systems, protecting sensitive data and building trust with your users. Authzed. Stop building Authz, start building value. All right. Well, welcome back, peeps. We are here with Sam once again, if you're coming back after the commercial. And thank you, Authzed, for sponsoring this episode, which is a perfect lead-in, Sam, to this. What is Authzed? Can you break this down a little more for me?
Yeah. Well, Authzed, pretty straightforward. We're working to fix broken access control. And the reason why is because we think that as developers, we a lot of times overlook access control because we're busy trying to build our own products. But as a business, broken access control can be a very serious issue, not just kind of breaking trust with your users, but it can be financially very devastating if you have data leaks, if you obviously expose information you shouldn't. And so we have expertise in access control, so we would like to take care of that for developers. And so one way we do that is we build authorization infrastructure for organizations so that they can kind of delegate that responsibility to us, and then they can go back to what they do best, which is build their own products.
Would you find if people are like very serious about this, do they actually start modeling this side before they even start writing code anymore? Or is it kind of, what does that look like if you are really serious about like the permission side of things?
Yeah, yes and no. I think it depends on your exposure to different access control models. Like I said, a lot of times, even very experienced developers aren't aware of different ways of modeling permissions and what you can and can't do in their applications. And so if you are aware, then sometimes people go all the way to the one extreme where they're kind of looking at formal models and mathematically trying to prove, that their access control is sound. But a lot of times people will just write a very comprehensive set of like integration tests, for example. They'll do like test-driven development. Our approach is that we have a flexible kind of configuration language that you can completely design and reason about your authorization model independent of application code, so that you can be sure this is the approach that you want. And then you can go integrate with your actual application. Awesome. And so cool. I think it's ideal to do this outside of your application, just because, it's a quicker feedback loop. You can test, you don't have to use your application test infrastructure to kind of try things out. And so it's just nicer to have it separate from code.
Nice. That makes sense. Very cool. And you developed kind of a database called SpiceDB. What's that based on, and why was it created?
Yeah, so SpiceDB is our primary open source project. I think the tagline we use in our GitHub repo is, open source database for scalably storing and querying fine-grained authorization data. So it's just a kind of nice way of saying this is the thing that you use to drive your application's permissions. So it's based off a research paper that Google published in 2019. That research paper is kind of in this like lineage of other very, very prominent research papers that Google has published that turned into some notable projects, things like Kubernetes. And actually, I linked that, or I posted that screenshot because Kelsey Hightower kind of does this nice, almost like history lesson of like the pipeline of Google research paper to open source project, and how SpiceDB and Zanzibar kind of fit into that lineage. And so that's just on like Authzed's YouTube channel, and you can kind of see that. But yeah, we read the paper. It was compelling, and we thought this needs to be made accessible, because right now Zanzibar itself is only used within Google to drive all the permissions for Google's applications. But the approach itself is interesting enough that we thought it would be useful for the general public. So we started building SpiceDB. Very cool. The name SpiceDB has another long history, but I don't know if you want me to go into that right now, or I can maybe give a short version of the history behind the name.
I'd love to hear the short version.
Okay, sure. Let me see how many.
This feels like maybe a Dune reference. I don't know.
It is a Dune reference, exactly. I don't know the ordering of things, but basically within Google, when they're supposedly building the project, they had this like mantra that the ACLs must flow, so the permissions must flow, which is a reference to the spice must flow. Zanzibar is the country. It has a lot of spices. And so I think that's where Zanzibar came from. But then SpiceDB is a reference to both the reference inside of Google as well as the Dune reference. Yeah, a couple things that I'll highlight about the paper. The paper itself is not too long. It's very accessible. It's actually a pretty pleasant read. But it basically has two main parts. One is kind of this overview of its approach to ReBAC. ReBAC as a concept existed prior to the paper. I think Kerry Gates introduced it in 2006. And that's just the general approach of like having relationships kind of drive access control decisions. But the second part of the paper is primarily a distributed systems design and like these scaling lessons that they incorporated as they were rolling it out to Google applications and the scale that those applications are trying to accommodate. So this actually very recently. This person kind of summed it up pretty well. He wrote like basically Zanzibar provides a few primitives from which developers can build really flexible authorization rules for almost any kind of application. The reason why Google built Zanzibar is because they only wanted to have one system, but then have every application use that system for their kind of unique permissions model. And so it's nice. You have a singular system, but n number of permissions models that you can build on top of it. And scale.
What are the benefits of the relationship-based model?
Yeah, I think intuitively, it's almost like easier to think about it, like almost going backwards. So how do you give permissions to someone? Well, think of this scenario. You're on a team. That team has something. That team has access to something. So you should therefore have access to that thing. With ReBAC, that's very natural. You basically have relationships. There's a team object that exists. Sam is a member of that team. That's a relationship. There's a document. The team has access to that document. And through those kind of almost independent relationships, you can figure out, ReBAC can figure out, oh, therefore Sam has access to that document. With other access control models, you could definitely model that, but it might look more complex. That even though that diagram there is essentially just a single line, when you expand out, basically, if you have this definition of what the types of objects and relationships they can have, plus actual instances of those objects, it forms a big graph. And so determining whether something has permission on something else is simply a graph traversal problem. So if there's a path that exists between two objects, then that permission exists. And so you can kind of see how that generalizes to, if you can define the objects and the relationships that you have, then you can almost model anything. And that's the power that ReBAC brings to authorization.
That's really cool. And I guess I should ask, SpiceDB is a graph database then?
So technically, no.
Okay.
So I think with graph databases, general purpose graph databases, they are purpose built to, obviously represent a graph and then do different graph operations on them. SpiceDB is not a general purpose graph database.
Okay.
It uses a graph under the covers to compute permissions, but it's a permissions specific database. It is not a general purpose graph database. Like I said, SpiceDB is inspired by the Zanzibar paper, but we had to add some additional things to make it general purpose. Used by the general public. Zanzibar has some assumptions, and it has that luxury because it's only used within Google. It has some assumptions baked in, and we don't have the luxury of making those assumptions because we are not Google. One of the assumptions that Zanzibar has is that the the subject or the actor in kind of when you make when you ask a permissions question. So can, user Sam do this thing? It's hard coded as like the internal Google user ID.
Okay.
And that's the only type of subject you can have. Whereas SpiceDB generalizes that. You can define your own set of subjects. So they can be a user, it can be a service account, it could be anything. And so we've added that functionality. And another thing we added is, we think, a more developer-friendly DSL to configure the types of objects and relations that a particular permission system is going to use when you add that to SpiceDB. So kind of like a relational database where, a relational database can model anything, but you give it a schema to say, oh, well, this table has these columns and, the columns look like this. And, you can basically write SQL on top of that. Same thing. So SpiceDB has a schema that defines objects and relations and permissions. And then you write data according to that schema. And then that's how the combination of data and schema is how SpiceDB knows how to compute permissions questions.
That totally makes sense. That's pretty cool too.
And there's a lot more that we've added on top, but that's probably better suited for maybe version 2 or 3 of this talk.
Sure.
And so I just kind of linked a paper that we published. It's kind of like it's like annotations on the original paper, the things that we added and the reasons why we made available as like this really nice PDF. And so if you go to that link, you can kind of download and get the information about all the extra stuff that we added and kind of the reasoning behind it, the design, all that stuff.
Very cool. I'll put that in the show notes.
Cool.
So this is kind of an example of SpiceDB in action, right?
Yeah. So this is an example of the schema. On the left is the original Zanzibar. They call it the namespace configuration. So this is what tells Zanzibar, for my particular application, here's how to interpret the relationships and objects. It is kind of readable, but you can definitely tell that it's an internal tool, because you definitely have to kind of know the secret sauce to write something and kind of make it intelligible. On the right, it's the equivalent of the same namespace configuration, but in the SpiceDB schema language. And it kind of looks like JavaScript-esque. It's a little bit dark, but essentially there's kind of 3 main things: definitions, which are the objects; relations, which are how those objects relate to other things with a type associated with it; and then a permission, which is, here are the actions that you can take on this object. And so the very last line has an example of the operations that we support. So permissions essentially can be composed of different relations. So an example for a document, for the view permission, it's actually defined as if you're all owners, all viewers, and all users that have view permissions on the folder that the doc belongs to all have view permissions. And so you can kind of think about this in a logical way where, okay, for a document, it makes sense that, people who have access to the folder can also access the document. Right. And so you can kind of represent that in what we think is a very kind of clear and easy to understand schema language.
And under the hood, is it producing what's on the left side then, theoretically? Or
No. So
okay.
We do kind of translate this into an internal SpiceDB, I guess, like set of configurations, but it's completely independent of the Zanzibar namespace config.
Okay, cool.
Yeah. And so I think recently, probably in the last couple of years, as Zanzibar has become a little bit more popular, the ReBAC and Zanzibar kind of UX, which is essentially can an object do this action on this other object? That style of authorization kind of question asking has become really popular because it's just intuitive on how you reason about permissions. And we've noticed that people have been applying it on top of a lot of different libraries and frameworks. How that question is answered is totally dependent on the individual library. Sometimes they're literally just kind of, it's role based, and so they'll kind of ask their RBAC engine, and they get an answer back, and you can essentially it's just a yes or no answer. So, but that UX has become really popular. So I think as people explore authorization libraries and like frameworks, you'll see this pattern quite a bit. Instead of saying, is something an admin, nowadays you'll see a lot of is this thing allowed to do this thing on this other thing. So you'll probably come across that quite a bit. And the reason I bring that up is that with SpiceDB, you get that nice UX, but also all the kind of systems lessons that the Zanzibar paper kind of introduced. So you get all this performance and scalability. And this is probably, again, maybe a topic for version 2 or 3 of this talk, but there's a very specific problem in authorization called the new enemy problem. It's basically, how do you prevent someone who used to have access to something that doesn't have it anymore from having access to something at a later time? And so there's a lot of work that went into making that UX performant in Zanzibar, and SpiceDB basically ensures that you get the same benefits.
And is there the concept of like date-based authorization type styles to things as well? So like, I think what that brought to mind is like an employee leaves, they once had access to things. Do you just remove them from a group, or like how does that actually work?
Yeah, so the idea of kind of linearization of events is important. And so, in real world terms, if you remove someone from a permission, you'd expect that to be, respected, when you go to do that thing in an application. And so, short version is that the new enemy problem is exactly that scenario you talked about. And the paper goes into detail about the technical approach that Zanzibar solves that. And we essentially were like, if they solved it, we'll do it the exact same way. So SpiceDB mirrors their exact approach.
It reminds me, like in my space, we talk about, and I guess it's yours too, like with JOTs, essentially like JOTs have a specific amount of time that they're good for and things like that. And we always encourage people, like, try to keep those as short as possible, because, with this new enemy problem or something similar to it, like when someone invalidates that, essentially, if you don't broadcast it out, which typically you're not because it's a pain in the butt, like that's why you don't want to have like a month-long JOT that's available. Right. So you fire somebody at the first of the month, they still have access to the 30th. It's not going to be great.
Right.
So
the new enemy problem version is that there essentially you get this token back with any sort of API call that you make. That token it's not a timestamp, but you can think of it as a representation of in that moment of time. And so the guarantee that you get with Zanzibar and SpiceDB is that as long as you are aware of that token, the person who had their access revoked will never get more access than they had at that time. So it's immediate. So think of a document example again. Let's say you had access to a document. You obviously can read it right now, and then you get fired. Let's say,
yep.
You're not gonna forget what you already read. But if there's an update to that document, you won't have access to that update. And so that's the kind of very clever workaround that they did. It's not that you don't get that document anymore. It's like, well, you already saw the document up to a point in time until you got fired. After you're fired, you don't get to see any updates.
Interesting. Yeah, very clever.
And that kind of really threads this needle around precise access control correctness, but also this is performant across a very large distributed system.
Very cool.
It's a very common question, authentication versus authorization. They are often conflated, again, even amongst the most senior of developers, because
it's challenging for sure.
It really is. Like, they're independent of each other. They're very complex, but they're always used in conjunction with each other because you have to.
They're like independent, but not. Yeah. Like it's so difficult.
It really is. You can authenticate someone, you can figure out who they are and validate it, but that alone doesn't really get you much. Nope. You need to do something with that identity. And then vice versa with authorization. If you can't have a trusted identity or kind of like an ID of some sort of who's trying to do what, you can't really make authorization decisions. So they go hand in hand.
I've made the argument in the past, probably wrongly, because I'm not as smart as the people that have written all these things, where I'm like, why didn't you just combine these from the start? Like, make it a zero auth if it just needs to be a user, and like things like that. It still bothers me, but like, I get it. I understand why they're separated and things like that, but we cram them together so often. It's ridiculous.
Really? Yeah, really. And I think, honestly, I think it's been that way. My opinion is how we got here is that for the vast majority of development, when we were writing software that literally was installed on your local machine and you were using it, it just was not a concern. Those applications are complex enough to just build. Why make a robust generalized solution for something that isn't important when it's just a program that's literally executing on your machine? Yeah. Fast forward to like web, I don't know, 1.0, 2.0. Finally,
everyone was trusted still back then.
Yeah. You could upload images and no one had to check what that was. Right. In that world. You kind of had a little bit more need for more robust application permissions, but really you just need to authenticate yourself. Back then it was just a username, password. There was no like
clear text
auth or anything like that.
Clear text in the database.
And again, people were busy building the applications, not the security around the applications. And then it exploded. Now it's more stuff happens online than it seemingly happens in the real world.
Yeah.
And so the complexity of what you do online matches that. And you can't just have, I'm going to say this, but you can't just have roles, because the world online is more complex than you have a singular role.
Yeah.
And applications are complex. You're not just doing CRUD operations. You're not just creating a document and editing it and deleting it. You're sharing them. You're, sharing them with a time limit. You are kind of forking them and managing permissions on your history of forks.
Yep.
The list goes on. And so not only do you have more complex ways and requirements around figuring out who is doing what, because now it's not just you doing it, your AI agent is doing it on your behalf. Your team of AI things are doing on it's that, combined with now you can do exponentially more things online. Both authentication and authorization are due for more modern approaches, but that doesn't mean that the work to build the applications themselves has gotten easier. So if you want to become an expert in your domain and authentication and authorization, that's a hard sell. And so I think both you and I can approach it as, well, we're experts in authentication and authorizations. Let us take care of that for you. Let us give you friendly APIs so that you can kind of focus on your stuff, and we'll handle the nuances and the complexities around these particular domains.
Totally. Something that we always drive back to, I'm sure you guys do too, is how can I make this not just easy for a developer, but where they're not providing it in a inefficient's the wrong word, insecure way. Even in our examples, we're always kind of pushed to hey, it's just a quick, here's how something works. And it's well, someone's going to take that into production and just use it. So make sure you're doing it the right way. And it's really challenging these days to not just, step one, have all of this in place. And that probably goes all the way back to my original question. Are you thinking about this beforehand? And it almost feels like, to some degree, you have to be. You can plug it in and separate it out and think about it more at the end and focus on your core needs. But you also have to be thinking about how is this going to plug in to the system as a whole. So even I've seen people write whole applications and then they're wait a minute, we just need a user ID. We forgot that in every single database we have. It's oh no. So It's just little things.
Yep. People, I think, for good reason, think, oh, we have JOTS. Why don't we just use that for permissions? And for a lot of applications, that is a good solution. And especially web applications, it's you already have, let's say, an authentication provider. They give you a nice user interface where you can define some permissions, and those come packaged into the JOTS that your application code receives. unpack it and do your thing. And I think that's why, when I go to conferences and chat with people, they're like, well, what do you do that's different from JOTS? Why can't I just use JOTS? And it's not like a either or. It's more, it depends on what your application is doing. And so this code snippet here is probably representative of the vast majority of authorization in a lot of web apps. And this honestly is just a snippet of code that I asked ChatGPT. I was like, give me an example of permissions using JOTS, and this is what it spit out. So it basically has like a general function that takes the claims from a JOT and kind of checks to see if the permission that you have is included in the ones that are sent in that user's JOT, and if yes, then you have access, and if no, then nope. And then that one example use of it is that I think there's like an API endpoint, admin/reports. It's like, who has access to this like protected resource? Well, anyone who has the read reports claim. Yep. Totally reasonable. Next slide, I kind of go into then, what if your application evolves? So all of a sudden, what if you have a need to say, oh, a user can read report 1, but they can't read report 2? Well, you can solve that with JOTS. You say, well, now we'll just introduce, you go into your admin portal, and then you say, okay, cool, we have read reports as a general permission. We need to add read reports 1 and a read reports 2. And then for the user, Sam, I'm going to give them read report 1, but they're not going to get read report 2. Done. You don't even have to change application code. Except, now multiply that by every user. It's like, well, they should have access to report 3, but not 1 and 5. And now you have like n number of read reports. And obviously, no one's going to do that. And then another scenario, which is, everyone on the engineering team should be able to read reports created by any other member of the engineering team. So it's like you give your team access. Well, cool. We can do that with JOTS. It's like, well, we just add a reports_eng permission, and now your application that function has to say read reports, eng or authorized read reports, and now your application code is changing. And so generally this phenomenon that happens as applications evolve is either called role explosion, okay, or custom authorization logic. Is now you're not just the application developer, you're an authorization logic developer. And so that's why, I say it's not an either or. You start this way, but when you realize that your application requirements now have evolved to the point where, maybe RBAC and JOTS aren't the actual best solution for what you're trying to do. That's why we're talking about SpiceDB and talking about ReBAC and talking about these other authorization models.
Yeah, I think this is a great highlight of it, and something that I don't even know, and I hope we kind of get to this and touch on it, is like what is the next step? Because I see so many applications, they're fine for the most part running up to this point, but then like, I want all the sharing capabilities that Google Docs says, and it's like, oh, wait a minute, like that just exploded everything. So let's talk more. And so I think it is that next step, and maybe you can get away with like some or most applications with RBAC and you're good, but like this gets back to my, I guess, comment or question again, is like, should you be thinking of this ahead of time and just have it done I'll say right way, but the ReBAC way of accomplishing this off the get-go?
One piece of wisdom that one of our customers told us was they were a brand new startup, so obviously building from scratch. Yep. And we asked them, why'd you start with SpiceDB? And their answer was, well, we know you can model anything else on top of it, so we figured we'd just kind of get it baked into our system, even though we're not doing anything complex yet. We know we're going to do more complex things later. Willing, God willing, like, as our startup succeeds. Sure. And so like, we'd rather just kind of evolve on top of a system that we know can evolve with us, as opposed to like, the MVP approach where it's like, we'll just get it working. Right. And then like, we'll just like take on some tech debt to like rip it out and do it again later. Well, it's like, what if you didn't have to have as much tech debt? And that was their kind of their approach. It was like,
that's kind of later. It's kind of what I'm wondering too. Yeah, it's very interesting. I think with AI writing a large portion of all of our code, it makes it a lot easier to embed these things and the people thinking behind it and saying, "Hey, we're going to do it this way. I know it's a little bit more complicated, but let's plug it in now, and so we don't have to like worry about it." And like, you don't have to write all the code to do all these checks and things like that. It's getting done for us. So just move as fast as we used to.
Yeah. And kind of this kind of slightly humorous set of steps, it's kind of a callback to old internet days again, is kind of like the answer to the previous kind of scenario I was talking about with JOTS. Is like how your application development might evolve. Like this is the alternative universe where with SpiceDB, this is how it looks. Like you pointed out, you model and validate your permissions outside of application code. We have a bunch of tools that help you do this. One of the kind of more user-friendly ones is our playground. I think it's just play.authzed.com. And you can literally start kind of creating whatever permissions model in there. And then you can kind of feed it data. And then you can add all these constraints to say, are these constraints satisfied? And yeah, you just kind of do it all in browser if you want to. And then once you're satisfied with that, you take that and then you go fill in the only the few places in your application code where you need to provide data. So it's kind of like writing a row in a relational database. You write a relationship inside of SpiceDB. For example, I just created a doc in your application code where you create a doc, you write a relationship saying Sam is the owner of this doc. And then you add the places where you actually need to check permissions. So when I go in the code that's, Sam's trying to read a doc, you do a permissions check before you give me access. You say, does Sam have read permissions on this doc? And those are the only things you add in application code.
Nice.
And then, yeah, profit.
Everyone wants to get number 3. So
yeah, go build the rest of your application.
Sam and I agreed this would be a good spot to stop the video and kind of make a separate video completely so that people get a better sense of how to use Authzed. He also walks through an Claude and an MCP server for AI. So it's really neat to kind of see how that breaks down. So go check out this video that we have linked here for the next portion of Authzed. Thanks, folks.